Can I start?
Yes.
Okay. Okay. So good morning, everyone. So I'm Koichi from Japan. So my talk, I want to talk about concurrency in Ruby. So I have 18 pages slides, so I need to skip many pages. So let's start. Okay, so Ruby has several concurrency supports like process, thread, and fiber. We already can use, and also we are discussing about new concurrency features like guild and auto fiber. So today I want to. So these features, every features has each characteristic. So I want to talk. I want to introduce all of them. Okay. So today we have many. Uh, I need to tell many things. So this presentation slide is uploaded already. So please check my Twitter account or something like that. So let me introduce myself. I'm a programmer from 2006. Sorry, I'm a faculty at 2006, and just now I'm a member of Cookpad. But I don't touch any Cookpad product, but implement the Ruby's batch machine, Ruby's core parts, like a batch machine thread, garbage collection, and something like that. So, so maybe most of you are working on the Ruby's application on or Rails application. So maybe you are here. So you make your application on the framework or other libraries, and as libraries are managed by Ruby gems or bundler, and they are executed as a Ruby interpreter. So maybe this is a normal developer's view, I assume. But I'm not a Ruby programmer, but an interpreter programmer. So I think this view is my view. So MRE developer thinks every application or library or framework is same Ruby source code, and we consider about how to execute the Ruby source code. So Ruby script is passed and make a bytecode and execute bytecode by batch machine and using garbage collector or threading systems or something like that. So my main work is here. So I made a batch machine for Ruby 1.9 and also make a threading system for Ruby 1.9, and I re-implement the garbage collector at the Ruby 2.1 and 2.2 and 2.3. So this means that I'm here. Thank you. So this is my introduction. So yesterday, he introduced several Ruby 3 goals. So Ruby 3 has, so Matz said Ruby has 3 goals. So static type checking and just-in-time compilation and parallel execution. So so static type checking is for productivity. So we need to implement your application. We want to implement our application as robust, no bugs or something like that. And we want to improve the performance. So yesterday's talk, Matt's talk say about MJIT. MJIT is one of just-in-time compilation. And another topic is parallel execution with a highly abstract concurrent model. So this is why I'm working on this kind of work, and this is why I talk about this today. So before the Ruby's concurrency, I want to define I want to define the word concurrency. So this is a quote from the Wikipedia. So let me, in computer science, concurrency is blah, 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 blah. So please read the Wikipedia page. So this is a very easy to understand the chart. So if we have a task A and task B, then if we try, so we can try task A and change to the task B, and this change back to the task A. So this is concurrent. So it is this is concurrent execution, and it is a logical concept. But the parallel execution is a physical concept. So we need to run task A and B in same time, simultaneously. So this is a physical concept. So this is so parallel execution is one of concurrent execution. So this is the difference of the concurrent concept and parallel concept. This is important, and Ruby or MRY only supports concurrent execution, so this kind of execution. Ruby, so one goal of Ruby 3 is to support this type of execution. But today I want to, I want to talk about this kind of concurrent execution. So at first, why we need to have such a concurrency support? So the reason is there is several kind of programs. It is easy to write a program with concurrent support. For example, please consider the program downloads several files from internet simultaneously, or web request, process web requests simultaneously. So maybe this kind of task is used by Rails programmers. And also agent simulation. So please consider computer games. So please remember that basket moving horizontally and dragon's egg fall vertically. So these characters, we can say they are agent, and each agent has its own logics and run agents simultaneously. We can make such a situation, such a program with concurrent support. It is easy to write such programs. For example, please consider the downloader from internet, download files A and B and C, and with concurrent support, we can make a download program and wait for receiving and change to this concurrent task and wait for receiving and for file C, and when the file A received as here, so we can do some post processing and so on. So at last we can finish the downloading A and B and C. So we can write this kind of program with concurrency with concurrent features, but we can make without concurrent support, but it's not simple and difficult, I think. So this is the thread using concurrent features thread, one of concurrent feature threads. So we make the thread, and so this thread block do the download file and write to the file. So this is very simple logic, and each thread run in parallel. In concurrent. So this program is very simple and easy to understand. So without concurrent supports, without threads, so for example, if we write this kind of program, so this program repeats download and file write for each URLs, but this execution is download A, and just after that, so continue download B, and after that download C. So it is not concurrent, and it has some several overhead. We can't interleave I/O overhead and so on. So it is not good for the. So we don't expect such a execution. So without concurrency support, we can write such a programs using the select. So register the register something with the file descriptor and check the file descriptor after that. So we can write, but it is difficult to understand and difficult to write. So this is why concurrency support is needed, I think. So after that, I will introduce existing concurrency support on MRI. So we have process, thread, and fiber. At first, so the traditional concurrency support process. So process uses operating system multi-processes. So use fork on Linux-like system, and other system can make another processes. So the characteristic of process is shared nothing model. So it means that we need to communicate each processes with some overhead. The programming is difficult to manage each processes and difficult to communicate each other. But debugging is maybe easy because only a few synchronization bugs. So we can make multi processes and run in parallel or run in concurrent situation. But if we need to communicate to each other, we need to use something like pipe or file. So we need to, so for example, if we want to pass this object to this another Ruby process, we need to serialize to the string and write a file or write to pipe and read them and deserialize the object. So it introduces some overhead. Sometimes it is good for good abstraction, but if we need to communicate to each other many times, so it will be a problem. And also, making a process needs some memory usage or something. So the process consumes several resources. Using process, we can use a fork and communicate with pipe. So this is a very simple process model, but it doesn't have some exception handling or something like that. So we need to care more and more. So for using multi-processes, Ruby has several libraries like druby or parallel gems. And also, Unicorn, the web application server, is also one of the framework of using multi-processes. Next is Thread. Thread is Ruby's native concurrency support. So if you write if you make a thread program with block, then block entity run in concurrent. In this model, shared the characteristic is shares everything. So each thread can access to any objects. So programming is very easy at glance. So this is a very important. So it is easy to write, but it is easy to introduce many bugs. So this is so difficult to make complete thread-safe program. So yesterday, someone explained about data race or race condition. So this is why thread programming is difficult. And the MRI thread has one restriction. So only one thread can run in same time. So only one thread have a giant lock. It can run. So for example, thread 1 has a lock. so thread 1 can run. But after that, pass the log to the thread 2, and thread 2 can run, and so on. So only one thread can run in the same time in one Ruby process. This figure shows how threads can share the objects. So we can share objects directly between the threads very easily. So it means that this object can read or can be written by each thread. So for example, outer variable or global variable or some other class variables or something like that can share each other by can share by this thread and main thread. So it is easy to communicate, but we need to introduce some synchronization for thread safety. So this is the same topic about yesterday's talk. So I want to speed up these examples. So this is a shared speaker object named Koichi, and my gender is male, of course. So please consider if I want to change this speaker to my wife, Yuki, and of course she is female. And so at first this thread A tried to change the Yuki, and this time Yuki is it says Yuki is male. So this is different, so incomplete information. So we need to change the gender, of course. So this is after that. If we read this speaker object from thread A and thread B, so it is no problem. There are no problem. But this is a problematic case. So just after change the name, and when thread B read this object, so this is incorrect data. So this is why thread safety is needed. So to avoid such a problem, we need to use some synchronization features like that. So just to modify or to read or write the object, we need to lock objects by thread A. So this timing, thread B can't access to the thread B this object because this object is locked by thread A. So this is the problem and how to solve this problem. But it includes some difficulty of programming. It means the advantage is very easy to communicate each other by each threads, but it is too easy to share. So it means difficult to manage all of them. So mutation, so read and write for shared object require the correct means a complete synchronization. So sometimes it is some objects are shared by implicitly. So programmers don't think it is shared, but sometimes it's shared. It is shared. So this is a problem. So this is what it's like Murphy's law. So if synchronization can be forgot, so this will be forgot, I think. So this figure is from shown at 20 years ago. So it's old presentation, but he says that thread programming is only for wizards. So this is Visual Basic programmers. So we can see it is old slide, but I think This this is true just now, I think. So this is a comparison of the threads and process. So communication is hard, and so for threads, communication is easy, but programming is difficult because of some synchronization, so making the thread safety. The last one is Fiverr, so user-defined context switching. So this is an example. So how many people use Fiverr? No one there. All right. So today you can learn. So please see this kind of program. This is the Fibonacci calculator. So this program's execution is like here. So blah blah blah. So it is very complicated. So maybe it is easy to understand. So main Fiverr resume. So continues the Fiverr, the start of the Fiverr, and calculate the first one, and suspend the execution and back to the main Fiverr. And after that, main Fiverr resumes the suspended Fiverr and continue to calculate, and so on. So the key point is the Fiverr can suspend and resume. So it is similar to proc, but proc only can call and return. So this is different. So proc can only call and return. So just after return, the proc need to begin at first, call and return. But the Fiverr can resume and Fiverr can suspend. So suspend and continue is a key point for Fiverrs. So we can exchange the internal iterator to external iterator. For example, Ruby's iterator is only for internal, repeating internal blocks, but we can control such a iteration from outside of block. So this one shows that so 2 times is 2 times. So it means repeat this block 2 times. But this program using Fiverr, we can continue this block for each from outside. Also, we can use this technique with each line, and also so we can use this technique without specifying the Fiverr itself. So enumerator next use Fiverr implicitly. So you only need to call next for doing such a thing. Also, we can use Fiverr for agent simulation. So this example uses cat and dog, but we can use a basket or eggs for this one. Also, another application is the I/O scheduler by Ruby programmers. So Fiverr, we can make using Fiverr, we can make our own scheduler. So, for example, if we manipulate the select or equal or KQ interface, we can implement our own I/O scheduler. For example, if some I/O operation is blocked, then continue to next Fiverr. The advantage of Fiverr is synchronization for shared data is not required. This is because we manage every Fiverr switching. So we don't need to switch to the danger point. So we can manage switching timing completely. So we don't need to afraid about the unexpected switch. And also, fiber is lightweight than processes or threads. So disadvantage is we need to switch explicitly. So advantage is we can manage switching explicitly, but the disadvantage is also we need to switch explicitly. So for example, if one fiber blocking the execution for one I operation, then we cannot continue all of fibers. So this is a comparison. So fiber switching is not fiber is not switched automatically, and we need to specify next fiber. But the communication and programming and debugging is maybe easy. By the way, I introduced fiber class at 2007. So this is 10 years anniversary of fiber. Okay, so these three features are existing features. So I want to introduce several proposed concurrency features. The first one is Guild, proposed for Ruby 3. Last year I proposed. So the problem of multi-threading is easy to share the objects between threads. So the idea is prohibit sharing mutable objects. So we set several goals for our new concurrency abstraction. So we need to keep compatibility with Ruby 2. So yesterday, Matz said about compatibility. So we need to continue to keep the compatibility with Ruby 2. We believe. And we can make a parallel programs. So we just now Ruby's concurrent features like thread and fiber cannot run in parallel. So Ruby 3 we want to introduce some parallel execution features, and we shouldn't consider locks anymore. So because it will introduce many bugs, many difficult bugs to debug. And we can share object with copy, or copy operation should be fast, or we should share immutable objects. So it means that immutable data we can only read. So we cannot mutate objects. So we only need to share. So we don't care about synchronization for such immutable data. And we can provide special objects to share mutable objects. So of course we need to share mutable objects. So we need to special way to share such objects. So this is the figure of guild. So guild has several threads, and thread has several fibers, and we can make several guilds. And each guild can run in parallel. So it means that the threads in the same guild, they cannot run in parallel. So they can run in concurrent way. So it is similar to Ruby, current Ruby, but thread of guild 1 and guild 2 can run in parallel. And the key point is we introduced a membership for the mutable objects. So all of mutable objects should belong to only one guild. So for example, this object is belong to they belong to guild 1, and also guild 2. This object and this object is belong to guild 2, and guild 2 cannot access to the other object. So this object belongs to guild 1. So guild 2 cannot access to this object. So only one guild can access mutable objects. It means that we don't need to consider locks. So we don't need to introduce any locks or synchronization features. However, sometimes we need to communicate objects. So we introduce a communication channel named guild channel to communicate to each other. And this communication channel supports copy and move operations. Copy is very easy to understand. So if we want to transfer object 1, and object 1 refer to the object 2 and object 3, then copy everything. So if we only want to copy this object 1, but copy everything refer from object 1. And the move operation is if guild 1 don't need to touch anymore for object 1, then we can send object 1 and referred objects, and also we invalidate from access to these objects from guild 1. So it means all the membership of these objects are changed from guild 1 to guild 2. Also, we don't need to care about a membership for the immutable objects. So the meaning of immutable object is object 1 and referred object 2 and object 3, everything are immutable or frozen. So then in this case, we don't need to care about synchronization so that we can refer such objects from guild 1 and guild 2. It is easy to understand, I think. So maybe most of objects should be frozen or immutable to utilize guilds. Using guild, we can make many programming models like master worker type. So make some guilds, so worker guilds, and send a task and back the wait for the result we can make with the channel, or we can implement the pipeline model. So using membership transfer. So this is a plan. This is a concept. So just now I don't touch about implementation of guilds, but maybe next year I will try to implement these features, and I hope we can introduce this feature to the Ruby 3 or Ruby 2.7 or 8. I'm not sure we can finish, but I want to introduce these features. So the characteristics of guilds is here. So the typical point is so we can run in parallel, and maybe the communication is easy if we're using the channel, and programming difficulty is easy, hopefully. The last topic proposed feature is AutoFiber. So Fiber enables. So as I said, Fiber enables to write a scheduler by programmer. So Ruby programmer can manage everything. However, manage everything is tough especially for normal program, ordinary programmers. So programmers need to write own scheduler is too hard. So we need to so that Eric proposed the concept and the implementation by this ticket named AutoFiber. So AutoFiber enable automatic schedules on I/O blocking. So making several fibers, and when one fiber blocked at some blocking operation or sleep or something like that, then switch to the next fiber automatically. So the advantage of this feature is we don't need to change the any existing source code, so we can run on your applications on AutoFiber. So switching, sorry. So we don't need to implement our own scheduler for the I/O operation, but Ruby can prepare the I/O blocking scheduler for several fibers. So advantage is we don't need to modify existing programs, and lightweight as a fiber. So lightweight than threads or processes. And we don't change. Preemption is not supported, so it is safer than threads. So disadvantage is introduce non-deterministic behavior like threads. So the safety is more safety is improved, but it introduces same type of danger of threads. So I think so each I operation can switch fibers. So it means that we cannot predict the switching timing. So we need to protect data with locks or something like that. So this is same as the thread safe problems. So I don't like this proposal because of this nature, but but it is safer than threads, so it can be introduced. And also, fiber means so scheduling manually, so in traditional way. So we need to change. I think we need to change the name of fiber. So this table is shows all of shows characteristic of AutoFiber compare with thread and fiber, and so switching on I/O blocking, it is made automatically, and next target is specified by randomly by scheduler. So this is the difference of with fiber. Okay, so today I talk about the existing supported concurrent features, process, thread, fiber, and I introduce a feature of under considered features, Guild and AutoFiber. And this is all of characteristics of these features. So maybe you understand this characteristic. I believe. So enjoy your Ruby programming and your concurrent programming. Thank you so much.
Woo! Give a big applause for Koichi. So, guys, you see, Koichi, thank you for the speak. And it seems that we still have a lot of time for you actually on this time slot. So, feel free to ask. Okay, let's start from over there. Sorry, sir.
Hello, Koichi.
Hi.
Interesting. I'm very interested about Guild.
Where are the? Oh, okay.
Oh, hey. So my question is, Can guild be categorized as a actor model?
Mhm.
If not, why? Or
Sorry,
maybe-
the question is, it's similar to actor model or from actor model? Sorry.
actor model as in concurrency pattern,
The
STM lock.
Yeah, so I believe Guild is we can make an actor model on Guild.
Oh, so it's compatible.
It's not an actor model, so we need to say the actor model is completely different computational model. ダメだ。So actor model is one. So Guild is not an actor model. So maybe, for example, maybe Erlang programming language or Exa programming language. They don't use actor model.
Okay.
So someone say they are actor model, but it is not. The actor model is different one. So Go language use Go routine and the channels. So they are, I forget the correct name, but there are several different computational model. But we can make we can implement the actor model on this Guild by library or some restriction for the Ruby programmers.
Okay. Thank you.
Okay, maybe we can go across the room first. Hold on.
Okay, I think so many people want to ask. Yep, people in the back.
Hi Koichi, thanks
Hi.
so much for coming to Indonesia. I like your presentation.
Thank you.
and I so much agree that trading is, I believe, only for wizards.
Mhm.
Yeah, my question is, right, so in Java, if not mistaken, we have like concurrent package. They have a lot of concurrent data structure.
Java you do concurrent you say.
Yes,
Okay.
correct. So with Guild, with Guild or Auto Fiber, it's possible that we, the Rubyist, maybe still not have a lot of maybe still use it wrongly
Mhm.
to make our program safe and etc. Do you think there will be a time that we have like concurrent data structure as well, and then
So the point is, point of concurrent data structure is we need to use it correctly. So for example, we need to so concurrent data structure is for the thread model or how to manage the shared objects.
yeah.
So we can use it. Of course, we can introduce such features for the threads, and actually there is a concurrent gem and so concurrent data structures gem.
Yes.
But the problem is we need to use it. So we need to use it correctly. So we can't do any mistake. And human being can mistake.
Yeah.
So this is my how to say, this is my opinion. This is my concept for Guild. So using Guild, we don't need to use such a misleading, difficult data structure. So we are free. So of course, using data concurrent data structure, so it improves the performance.
Yes.
But it introduces some difficult some problems. So this is what. So and Guild is not optimal, performance optimal, not performance optimal. So maybe it is similar to C and Java or C and Ruby. So C language doesn't have garbage collector, and Ruby has garbage collector. So without garbage collector, it is fastest. It is optimal for performance, but we don't want to free anymore.
I see. Understand.
So this is a productivity and performance trade-off,
okay.
I think.
Okay, thanks.
Okay, the next
Okay,
question.
interesting. Next question. You pick, Yolanda. You pick.
I really want to choose a speaker in the front, but I think they really excited to us. So sorry.
Thank you for choosing me.
Oh my God, that's deep.
Oh, is that a prize? Oh, is that a prize?
That's deep.
Thank you for the talk, Koichi-san. And I felt the guild, the model of guild, much like the ownership model of Rust language.
I see.
And my question is there any origin of the idea, or did you invent the model?
All right. So the question is the origin of the concept of guild.
Yeah.
Okay. So, so as you say, so this is similar to Rust. The Rust has an ownership model, but it's managed by types, and Ruby doesn't have types. So this is why we can't use a similar idea from Rust or other research ideas. So, and the ownership or membership, I think there are no such a membership or ownership model of for the dynamic programming languages. So traditionally, so there are many research for the ownership, but these research are only for static type programming languages. So they are managed by types. So my new idea is introduce such a ownership model for dynamic language.
Thank you.
Thank you.
Thank you. Okay, next.
Okay,
Maybe I
you
will
want to
choose-
choose someone?
You want to choose someone, Koichi?
Okay, so near to the microphone.
On the other
Okay,
microphone?
I'm near everyone here. I'm in
Everyone
the
is near
middle.
the microphone.
Okay.
Following from that, I think this is a very good opportunity to segue. I read somewhere that you looked at Racket's concurrency model, and actually a link to a specific research paper.
About what?
Guild
Mhm.
comes from a similar idea
With
that was
Rust.
implemented in Racket, the Racket
Rust?
programming language. Racket,
No, Rocket.
Racket, yes.
Yes. So Rocket has a similar idea, place.
Yes. Places, yes. That's
Yeah,
right,
yeah. So
places,
place,
yes.
but place is so place. Yes.
Yes,
So
a comparison,
I remember
yeah,
that.
yes.
Okay. So place only supports copy everything model.
Mm-hmm.
So the new idea is support move operation. So this is a very slightly a small new technique, but it's different. So
So you're saying with guilds, the difference between the two is that with guilds, because you have immutable objects,
can share.
they can be
We
shared.
can-
Is
we
that, is that
share.
what is that the difference that you just mentioned?
I
I didn't catch what you said just.
I don't remember correctly, but maybe place has so if we make a places
Yes.
and the place has their own heap,
Okay.
but on guild we share all of guilds share the full of one object heap.
Okay.
So this is why the moving and sharing the immutable object is easy.
So
Maybe-
it's actually quite different then. Guilds is quite different from places.
It depends on the opinion. So
Yeah.
so someone can say it is similar,
Yes.
and someone. So I want to say it is not so similar.
Where I'm coming from is that, suppose I wanted to read a kind of a formal spec on guilds. And now you come from a academic background.
No,
do you
no, no.
plan? You do come from
Yeah,
academic background, but you're not
background,
working in
I-
academia anymore. So the question is, do you plan on publishing a paper
I
on the
want to.
guild concurrency model?
I want to.
Okay, it's
Thank you.
okay. I think for one more questions.
Yes, one more interesting question. Go.
Itu, That one, in the middle, near the camera.
Okay, I just want to ask about immutable data type in Ruby. With guild, you say that the var become immutable. So if we declare a variable inside a guild, how long it become immutable, or all this life cycle it become immutable, or it can be released? Like we state, the only way we make variable or data type immutable is froze it. Yeah. But if in guild we declare a variable, whatever it is, would be it frozen all the time, or it has life cycle, or if it copied, or if transferred, will be then new object in other guild become frozen also? Like that.
So maybe this is a good point. So just now we don't have any idea for how to make a frozen object. So so in my opinion, so all of operations should be compatible with Ruby 2, and most of object creation is making mutable objects. So we need to introduce some kind of method to create immutable data sets. I'm not sure. But it should be one idea. What?
Thank you. I sneaked into my question. How would you do that? Like if you have a deeply nested object graph and only the top object is frozen, how do you know that the graph is frozen?
So we need to check we need to traverse all of objects. So just now.
Okay, let's go. Okay, I think it's enough. Time is up, and you guys can ask the question directly to
To
Koichi
Koichi after
after
this.
this.
Give applause for Koichi, guys.
Thank you so much.
So.
Thank you.